Now let's start with the code and understand how to perform face detection using OpenCV and Python. This is the Jupyter notebook which I have opened. Click on the new and create a new file. I have already created a new file. Now just rename this file. The name I have given is face_image. Now let's start with the code. So the first step is importing the required libraries. Now we are going to import OpenCV package. So it is a computer vision library. In simple language, the library which is used for image processing. All the operations which are related to image are easy with this library, and this library is free for use. After importing the library, the next step is just run this line. Okay, so this library is properly imported now. Now the next step is we are going to load the cascade. Load cascade. Okay, so whatever the classifier which we are going to need now for face detection, we are going to load that. To load any classifier, there is one method which is cv2.cascade classifier. So create any variable, okay, and use method cv2.cascade classifier, and here we need to pass the path. Now this is the path of my cascade. Just copy and I'm going to paste it here. So this is how I'm going to load the cascade classifier. Okay. Now if you want to check this cascade classifier, if you want to locate this cascade classifier, this classifier is located in your Anaconda folder. So this is my main folder. This is the main folder, and in this folder, in Anaconda 3, in libraries, then so this is where all the classifiers are located. So this is the path which you have to copy paste, and you have to paste this path in your file. So these are the different cascade. So this is cascade for eyes detection. This is cascade for eyeglasses. This is full body cascade. So this classifier is for smile detection. And so these are the different classifiers which are there. So you just need to copy paste the path and append the name of the classifier which you are going to use with extension which is XML. Okay. So if you want to copy paste the path, you can do like this. For example, now we are going to use hair cascade underscore frontal face underscore default. Okay. So right click here, go into the properties, and from here you can check the location of this classifier. Just copy paste this, and this is the name of the classifier. From here you can copy paste the name of the classifier, and you just need to add the extension which is .xml. Okay. So that's what I have done. So this is my classifier. So this is the path of the classifier till data, and this is the name of the classifier which I'm going to use now with the extension which is XML. So either you can directly give the name of the classifier if this classifier is present in your current directory. But since my classifier, this classifier is not in the current directory, I need to pass the path. Okay. Current directory means, for example, if my classifier is here in this folder. Okay, this is the current directory. If my classifier is here, then I don't need to give the entire path. With the help of just the name, I can load the classifier. So just load the classifier, run this command. Okay, the classifier is successfully loaded. Okay. The next is we are going to read the input image. Okay. So whatever the image is there, I need to load that. So before that, what is classifier? Let me explain you this in brief. So OpenCV provides pre-trained models that can be used to read the image, and this is the method which is used to read the image, and you can use this method to detect for face detection. So here we are going to use hair cascade model to detect the face. So this is the model which we are going to use to detect the face. And after the installation of OpenCV, these pre-trained models are located in the installed folder. As I showed you, after the installation, you will get to see all these hair cascade classifier in that particular folder. Okay. Then, so this is what hair cascade classifier is. So these classifiers are all XML file which we saw just now, and our input image will be compared with the data in this class, and then the face detection will be performed. So whatever image you're going to use now for face detection, that image will be compared with the data in this classifier, and then the face is detected. Okay, so this is how our classifier works. Next step is we are going to read the image. We are going to read an image. Okay, so for this we have a method which is ImRead. So image is equal to cv2.imRead. So in this method you can pass the name of your image, or you can pass path of your image, and there are two parameters you can pass. One is path and second is flag. So the syntax of cv2.imread is cv2.imread. You can pass path and flag. Okay. So if your image is in the current working directory, then you don't need to pass the path. You can just pass the name of the file. And if your image is somewhere else in some other folder, then you need to pass the path as well. So this method loads an image from the specified location, and if the image is in current directory, you just give the name of the image. As my image is in current directory, current working directory, so I am just going to pass the name of my image, which is team.jpg. jpg is the extension of my image. Okay. Then as well as you can also give another parameter which is flag. For now I'm not going to pass that parameter, but flag is basically an integer value which specify how you want your image. For example, if you want to load color image, then here you can specify 1, and if you don't specify 1, by default it loads the color image. If you want to load grayscale image, then you can specify 0. If you want to load some unchanged image, then you can load you can write -1. So in this way you can provide different integer values for the flag, and you can load image as you want. Then just run this. Okay, it means that my image is now successfully read. The next step is I am going to convert this image into the gray color. Okay, so let's convert it. To convert any image, there is one method which is cvt color. Okay, so cv2.cvt color, and here we will pass our image, and we will pass the conversion method. So conversion code is cv2.color underscore bgr to gray. Okay, so this is the color code. This is the conversion code. So what I'm going to do here is, so cv2 color helps to change the color space of an image. So there are around 150 color spaces method in OpenCV. So we are going to convert this image into the grayscale, and we are converting this image to grayscale because as grayscale contains less noise. So that's why we are converting. In the cv2 color, you can pass 4 parameters. Like first you can pass the name of the image. Then then second parameter is the conversion code. Then there are 2 more parameters like output file, and some optional parameters are there. For now I am going to use the 2 parameter, which is the image and then the conversion code. The conversion code, there are almost 150 color spaces. So you can also write code like color underscore bgr to hsv. So this is the another code which you can use. So just run this. Okay. So in this way, we have successfully converted our color image to gray image. Detect multiscale. Now this method actually detects the object. Here we want to detect face, right? So the method is cv2.detect multiscale. First we will write code faces is equal to face dot detect multi-scale, and here we will pass certain parameters. Like first we will pass the image, grayscale image. Then we will pass the scale factor. So here scaling factor is 1. Scale factor means which increases or decreases the image according to the algorithm requirement. So here you have to provide the scaling factor. Then minimum neighbors. So here minimum neighbors is 4. Our classifier contains too many images. So here if we specify 5, then algorithm stop comparing after finding the 5 equal images. And if you set this to, for example, 6, then if you set 6 images, so it requires 6 images that must match with our provided image to detect a face. Then next parameter is minimum size. Minimum size means if object is smaller than minimum size, then it will be ignored. For example, if the face is smaller than the minimum size which I am providing here, then that face will be ignored. So in this way you can set different parameter. For now I am going to set grayscale, image, then scaling factor and minimum neighbors. So here let's set it 4 and just run this code. Okay. Now the next step is I am going to draw the rectangle around the face. So after detecting the face, my algorithm or my code will draw a rectangle around the face. So I'm going to write one function which returns the rectangle where algorithm found the face. Okay. So write a for loop and then cv2 dot rectangle. I want to draw rectangle on image, right? So pass the image, the name of image. So here is my image, right? Then pass the coordinates x comma y comma x plus w comma y plus h. Then pass the color code. I want green color, and then pass the thickness of the rectangle. Let's run this. Done. Next is I want to print the number of faces found in the image. For example, if my image contains 4 people, then it should return 4. If my image contains 10 people, then if I want to count the number of people in my image, then there is one method which is length. With the help of length method, I can count the number of people in my image. So it's very simple. What I'll do is I'll write faces found and length of faces. So here I'm going to pass this, okay, length of faces. I'm not going to run this code right now. Just keep it here. Okay. Now next is, now I want to display the output. To display the output, there is one method which is cv2.imshow, and here you need to pass, you can give the name to your window. For example, faces found, I'm giving this name, or faces in the image. Okay, so this is what title I have given to my window, and then you need to pass the image, and finally cv2 dot wait key. So wait for user key to terminate the program. Okay, now let's combine this code so that, okay, now run this last few lines. Okay, we got some error. CV2 dot wait key. Okay, so key is capital. Close the program. Close the program. Okay, the kernel is restarted. Run this line, run this line, run this line, and just change here K is capital. Okay, K is capital and run this code. See, so this is the output of our program. Okay, so in our image there are 5 people, that's why faces found 5. In this way you can calculate or you can count the number of people in your image very easily. And this is the rectangle and the color is blue. Okay, this code is blue. So if I just change this code, let's see what is the output. First I need to close this program and then run this code. Now see, the color is changed. Also you can change the thickness too and just change color. Run this. See, the color is changed. Okay. So in this way you can easily do face recognition using hair cascade frontal face default .xml classifier, and you can use different color and different thickness, as well as you can draw circle around the faces. So this is how you can build your simple face detection classifier.